Hello and welcome to this webinar from Real Resilience. My name is Iain Betson. Now, Real Resilience is a tape machine services company. We maintain and repair machines. We're based in the UK. We have a website, which is www.realresilience.co.uk. And on there you can find various things such as our Press Play podcast. The last 5 episodes are available there via Mixcloud. And we also have that available on all the places you normally get your pods, such as iTunes or Spotify. You can find us on YouTube. We have a YouTube channel, Real Resilience, where we have uploaded all the podcasts, and also I'm putting other videos up there as and when we go along. And finally, the Facebook page. I know many of you have found me there, so coincidentally enough, it's called Real Resilience. Now, this webinar is the second in the series. It came off the back of one I did on the audio lineup of a tape machine, and I will be putting that up on the YouTube channel next week as sections, because it's about 70 minutes or so long, which is about the length of this webinar. We'll see how we get on, but I do aim to, as well as covering the breaks on the tape machine, have a Q&A session if possible. Just send your questions in. The Q&A box is open and I'll do my best to answer them. And if we run out of time or some of them defeat me, perhaps I'll put it out to those people who are viewing today, or I will get back to you at a later date, but I promise you I will do. We've already had 2 or 3 questions come in, which I'm very pleased about, and I'm very glad that you have actually bought a ticket to attend this webinar. So the subject of this webinar, it's one of 2 areas that I feel are the most important part of a tape machine. Yes, recapping and headwear is important, but frankly, if you have poor tape handling, then really your audio can be absolutely perfect, but if your machine reduces your tape to a bootlace or spews it all on the floor, well, we're going nowhere. Now, those 2 aspects are tensions, which I hope to cover at a later webinar, and the subject of this one, brakes and braking system. I've decided, because we had to choose a machine to demonstrate the brakes on, to choose a Studer Revox, because they're so prevalent. And I do apologise if you don't have a machine like that, perhaps a Studer or a Revox. But if you've got, say, a TIAC or a Sony, you will find that some of the things that I'm covering on this webinar will be applicable, because basically the braking systems on sort of high-end domestic, semi-professional and professional machines by the late 1960s, early 1970s, they were all pretty much the same genre, whatever manufacturer you had, which it basically involved a drum with a band around it. Now, whether the band was abrasive and the drum was smooth or vice versa, it didn't really matter, but the principles were the same. The other thing you'll find is, depending on the action of the machine, whether it was in rewind or fast forward or play, the braking had to be variable depending on what the machine was doing. So our machine today, we are using a Studer B67 Mark II. This is one of mine. I've had it for about 10 months now. If you saw the post on Facebook, probably around about September, October, you might have seen me taking the case. It's a standard Studer trolley with an A80 or such, some such would go in it. And I was so annoyed with cleaning it all, I took it out to the back of my house, to my garden, and took the machine out, obviously, and jet washed it. And it came up very, very well. And I have given the machine a good clean, but other than that, there's not a lot I've done to this machine, because I just haven't had the time with so many other bits and pieces that I'm doing. So really what we're going to do now with the brakes on this machine is pretty much almost for the first time. The other thing is, those of you who might know this, the 67, it's got loads of riffer caps in it. I've already had one question in from an attendee about their A80 that's spewing smoke out to the and they wondered what it was. Well, that's likely to be your riffer caps that have gone pop. Now, the riffer caps, and you'll soon learn, live around by the spooling motors, the take up and supply spooling motors here. And age gets to them, and when they go pop, you get clouds of white smoke come out. It's not the end of the world, I should hasten to add. Your machine will still survive. It's not advised that you carry on using it with those blown riffer caps, but quite honestly, just turn the machine off and very little damage would have happened. But who knows, the 67 was known for the riffer caps going pop, so we might get some fireworks live on air. So, as I said, some of the things that be applicable to other machines, and also whether you're doing checks on your machine, the braking system, checks on the machine just as a general service and find out what they're like, or you want to see what the brakes are like when you're buying a machine. One of the things you can do with Studer Revox is just do what I call the Studer click to check what how the brakes are performing. With the power off on the machine, and I've just done it on this this hub here. If you can hear it. And notice as well that the supply spool is also moving because the brakes are interacting with both hubs. But if you can hear that click, that is the brake mechanism, the rough drum, the abrasive drum with the smooth brake band around it gripping. If it doesn't do that and it's all silent, that's likely to mean that your brakes are completely worn out. Similarly, if it's a big old graunch backwards and forwards to turn them, chances are your brake systems have binded up and they've locked, and they're certainly not going to be doing their job. So that's one test you can do just with the power off to check, everyday check on the brakes. Yeah, what are they like? I find myself going up to Studers quite often in new machines and just that I've seen and just, yeah, that sounds all right. The brakes are in pretty good nick. How you get the feel after time with doing this backwards and forwards. Yep, I can hear the click, the brakes are okay. So you'll just learn that. The next thing we need to do, if we just find a spool, is put that onto the machine and lay some tape up. I am using, and I do stress this, gash tape, any old tape. We are testing the brakes on this machine. If they go wrong and it spews tape everywhere, or even worse, snatches the tape and turns it into a bootlace, we do not want air pressures recordings ruined. So we are just using gash tape here. Power the machine up. You notice there was some clicks and movement there. That's the brakes. That's the brakes working. And just put the machine into a few operations. Good if you just want to do some general checks or want to see what the machine is up to if you're planning on buying it. Notice I'm putting the machine through a bit of a workout here, straight into fast forward, back into rewind. Some Revox machines won't do that. You have to go through stop, but the vast majority probably will. I'm thinking specifically probably the A77, B62s, A62s. You had to go through stop on there. But one of the tests you can do is go from rewind straight into play. Get the machine running up to rewind and then go straight into play. The machine's got a lot of work to do. Slow the tape down, bring the pinch roller in at the right speed, and start it playing, all without shedding tape. See what it's like in different speeds as well. Now, we're not really touching the brakes here, but this is a good test that you can do for your brake system if you are buying a machine. Put the machine into fast forward. On any machine you can do this, regardless of what make it is. Get it up to a good speed and turn the power off. It should not spew tape all over the floor or snatch the tape. If it's snatching the tape in fast forward, it means this braking reel is acting far too fast and therefore snatching the tape. If it's spewing tape off, it means that the brake is not working well enough, and therefore it is not braking as hard as this side, and the tape flies off the machine. Conversely, if we go into rewind, get it up to a good speed, it won't hurt it to turn it off. Turn it off. Notice the tension arms on this machine go down to try and take up the slack. The tape should not come flying off the machine. It's a good test of the braking system. The reason being is that when the power goes all off the machine and the brakes have to do their work mechanically, there's no back tensions involved. They have to do all the friction stopping. So so that is why you turn the power off, and that's a good test. So let's just turn our machine back on and rewind the tape, because we're going to look at what is actually under the deck plate of our B67 Mark II. Turn the machine off. Do that with any machine that you are working on. Take our reels off. We've got a deck plate here with the 67 A810, so the A800s, you took the top plate off to take the machine off. Same with the A77s, B77s. B62s, AB62s, you couldn't. You had to work from the back of them. And indeed, if you've got a TIAC or a Tascam machine, a lot of the brake mech is on the back of the machine. So you're taking the case off to get to that. Depending on the machine as well, you will need to take the head block off. A77s, B77s, you don't need to, but you do on the A807s, A810s, that kind of genre machine. Tension rollers, I usually put them one either side. If you want to keep them together, it's not the end of the world if they get swapped over, just but for the sake of this webinar, I'm keeping them together. The head block itself, if you need to remove it, most tape machines have this 3-point system on them, 1, 2, 3 bolts. I've already eased those off, and then we just take the head block off, hopefully. No, I did nip the screws in down here to just to release the head block, so just to hold the head block in, I should say. So you need to just unscrew those bolts there, and I did that, most of it for the speed on this webinar. I will be telling you about the tools, the various tools that you need, regardless of what machine you've got, as we go along. So that's your deck plate off. Sorry, your head block off. Most of your fixings on a deck plate are 5 bolts, 4 or 5 bolts, in this case on S67, 1, 2, 3, 4, 5. A77, they're push mounts, but the vast majority of them, B77 and what have you, it's screws and bolts to hold them in. I've taken these all out for speed of the webinar, and we just release that and take the deck plate off. And there we are, we have a naked B67. We need to reassemble it a little, somewhat, so we can do some other checks and lay some tape up on the machine, and also just keep track of all their parts. So we'll put our tension rollers back on. And we find our head block again. Very careful when we put the head block back on. We've got a lifting solenoid here, which activates when we're in wind and rewind, and this will lift the tape away from the heads, so they're not scraping over the record and replay heads. This is our pinch roller solenoid, and which will obviously go in with the pinch roller, and of course their capstan here. Tension arms, depending on your machine. Again, that's a little bit off the bounds of this webinar, but this is obviously where the tension, the machine gets its tension and passes that back to the spooling motors. So let's put our head block back on. Very carefully as you put it back on, because you don't want to scrape it. Some head blocks you do need to desolder them, unfortunately. A good example would be the 77 A and B 77 machines, but a lot of the fully pro machines, you can just take them off with a connector. Incidentally, another quick tip, if you're putting your block on, just give the capstan a bit of a rotate there. You can see that. I'm just giving that a bit of a rotate. The reason being is this is all metal around here, and if you have that too close, when you power the machine up, the capstan will burst into life, and you'll hear scrape, 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 scrape. Not going to do your capstan a lot of good. Just going to nip one of the bolts in to hold it, to stop the capstan, the head block moving. And then we put our pinch roller back on, because we will need that. Just hold that back on there. So that's the bits down here. This is the bit we've come to talk about in a webinar, the braking system. Most of the braking systems on across a vast majority of machines all rely on the solenoid action with a brake band here and a brake drum underneath the spool platter, underneath this bit here. Occasionally we have this other edit action. You'll find on some machines we'll have another edit solenoid, but the vast majority of them, brake band, whether that's got the abrasive material on or it's smooth, and some levers to do the action. This is why when I was moving one of the, doing the Studer click, that's why the other one's moving. Incidentally, if you can see that, this is the bit that's going click, 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 and this is the important bit. And you do the same with this one. You do them in opposite direction to the play. So basically, that's a rewind direction for the take-up spool, and that's a fast forward for the supply spool. And they find that that click is these arms of these brake bands hitting on these lifting pins. Now, if we just go back to a few photos I have here of tape machines on our PowerPoint presentation here. And I'm just going to put that on the screen for you so you can see. This is taken from the B67 Mark I manual. You'll see it's broadly what I've been speaking about here. You've got your brake drums, you can see in the center of the picture, and then you've got your platter where all your levers for your braking mechanism go, and the brake band around the drums, and the springs to hold them. Moving on a little bit, we've got some. If you're into naked tape machines, you're in the right place. The B77, as you can see, we've got basics up here. It's a simpler braking mechanism than the 67. We've got a solenoid which is mounted here, and air lever arms and air brake bands there. I don't know whether you can actually see that if I put that on the screen. It's a good pointer again if you're buying a machine and you think, what's its history? Look at the spool platters. They've got different bolts in them. There's cross heads on the take-up side, and on the supply side, they've got cross heads. That's interesting. Clearly, at some point, that machine has had some maintenance done on it, and the bolts have been lost, and whoever's done it has just put in some generic screws to hold the platter on. It's a good indication of the history of the machine. If we move on with our machines, this is the A807. Now, surprisingly, the A807 was probably classed as a high-end professional machine, but it was really the swan song of Studer, brought out in sort of 88, 89, and they were making compromises in the build there, I'm afraid to say. Consequently, you find you've got a very simple braking mechanism here. And interestingly, going a little bit off a piece from this webinar, we've got a tension arm arrangement down here, and the A807, they saved a lot of money in the mechanics by only fitting one tension arm and letting electronics sort the tensions out. But they also made compromises with the braking system as well. Moving to the A810, the B67 took passed a lot of its heritage over to the A810. It's really the successor to it. And here you can see the A810's braking system here. We've got air levers here, and with the solenoid, and then we've got the edit solenoid and the edit levers, edit solenoid levers at the top there with the bands under the platters. Let's jumping up here. Now, this is an interesting one. This is the A820 MCH, A820 24 track. 2-inch tapes of 14-inch diameter reels can go on this machine. And that's a lot of weight. If you've ever picked up a 2-inch reel of tape, you'll know how heavy it is. Although they haven't got the arms which link the two braking systems, they're still using the braking bands and air solenoids here, 2 solenoids here and here. Just put that on the screen for you so you can see it a bit more clearly. 2 solenoids and a braking bands. And those brake bands, brake drums, are not dissimilar to the ones we will be looking at on the 67. And I find it quite amazing, really, with all the physics involved in shifting large amounts of tape around, that they still rely on these drums with a little bit of abrasive material and a piece of metal to slow it all down. But that is a 2-inch A820 multi-track braking system. Jumping away from Studer, but showing things are applicable, Sony TC765 uses the same thing. 2 solenoids, similar action to a similar operation than the A820. But what's interesting here is, as you'll see with the Studer machines, they have got a lining around the drum and a smooth brake band. Sony have reversed this, and they have a smooth drum with an abrasive brake band. They also have this kind of guide around. Again, I'll put that on the screen for you. They've got this kind of guide around the drums, and you'll find that on A807s as well. And the idea is to keep the band in contact, or a distance, a fixed distance away from the drum, all the way around the circumference of it. So that's why you get these braking bands around there. I do promise you this won't be a sort of a view of all different braking systems, but it is to illustrate the braking systems across a variety of machines. The TIAC 410 SL, I like the little TIAC. I've got one myself. This is actually my machine. I like the big VU meters on it, and they're very nice. But it's a bit of a cheap machine because it only takes 7-inch reels. You think, oh, this is quite wide. It'd take big 10.5-inch. It only takes 7-inch reels, which is a real shame. But you can see the approach they've gone for as well. This is what I said, that their braking systems are fairly generic across a lot of manufacturers. A solenoid's up top there, a braking arms there, And TIAC have gone for the abrasive brake band and smooth brake drum, as you can see there. Finally, or a couple of the we've got here, I should say, A77, similar thing with the arms, but there's a slight difference here, and I don't know whether you can see it. I'll stick that on the screen, and also give you a close-up of it. It's got this kind of arrangement here. If you can see the top pin, where the brake band goes off, and it's kind of got this Y-shaped metal piece at the top. I'll just show you there. It's got the brake arm band there and this metal piece there, and it's not something that I've seen actually. If you're an A77 aficionado, I'll be interested to know what the thoughts are behind that, because the A77 is up to 4 marks, I think it got to. Plus they threw the Dolby version in as well. That when they introduced this, because it is a departure from the norm of normal Studer Revox braking systems. You can see the drums around here as well. That's with the brake lining. A77 drums are different to the drums that we'll be looking at this afternoon. They're quite thin and specific to the A77. The final one, before we get back into the nitty-gritty of changing all these bands, is the 62, the AB62. I do apologise that the quality of this is not good. I don't have a picture of an AB62, A62B62. Put that on the screen for you there. This was taken from a scan from the manual. And the approach there was completely different to normal braking system, normal Studer braking systems that we've just looked at. In terms of, it had, if you can see the braking drum just above that red circle, I'll come on to that in a minute. It had a stacked braking system of 2 bands and two abrasive linings on the brake drum. So the brake drum was about 4 centimeters high, and it had the platter on top of it. And this is the braking and edit solenoids. You can see there the brake solenoids are the dark sort of squares in the center of the image. And so it had stacked braking system. And incidentally, this picture is taken with the whole braking system removed from the system. You cannot see that on a A or B62 by taking the deck plate off, because you can't do it. You have to take the whole braking neck out to get to it. Now, the reason why I've got this picture, if you've got an A or B62 and you don't know about this, in that circle is a replay head. What's a replay head doing on the braking system? That is because around this drum, and the 2 drums are different incidentally on these machines, around this drum is a piece of magnetic tape. And recorded on that magnetic tape is a series of pulses, which this replay head reads, and the machine uses for tape tensions. How fast is it going? And it reads the pulses off there. So you've got to be very careful when you're doing your audio lineups with your demagger and waving that around, because I have actually seen those things get demagged. And also, if you don't set the brakes up properly with that head, the head graunches into the drum and ruins the tape, and then the poor tape machine doesn't know anything about tensions that it's getting off that pulse tape. So that's why I've just highlighted that there. Let's go back to our 62, because that's what we're, or 67, I should say, because that's what we're here for, and start looking at the braking system there. Tools you're going to need. Well, I've already used the standard Studer Allen key or hex driver. So that's one tool you're going to need. Also going to need a smaller version of that. Most Studers you can get away with, I think it's about 3 of these tools here. I've got another shot, if you can see that. They're another shot of the work I'll be doing, but they're the 3 hex tools you need, and of course the screwdriver to take off the spool platters. Again, I mentioned with that B77 that has got different screws on the spool platters. This B67, I only noticed this when I when I literally got this machine up here to do this webinar, started taking it apart to make sure everything was okay to do the demonstration. It too has different screws. You might not be able to see them. Let's see, this camera's a bit better resolution here. You might not be able to see them, but they are the original Studer screws. And again, someone has probably lost the screws and has just substituted some standard posi screws on in their place. So Here we are. That's the underneath the braking system. We've got our braking drums, we've got our bands, and we've got all of the mech. The drums themselves, they are just bolted down to the spool motors via this bolt arrangement, and the bands are just held on by these posts here. They go through to the lifting pins. They're held on by a screw, a spring arrangement to hold them in position. There's various springs to hold the edit spring levers and the lift levers in place. I will be covering, as well as changing these bands and the drum. I'm only going to do one side for the sake of speed, but you do one side exactly the same as the other, and I do recommend you do one side and then the other, for the simple reason you can copy where the spring positions are. Yes, the spring positions will move depending on the braking forces you set up and when you come to measure them, but they're a good starting position as to where the springs are. So don't strip the whole thing out and then put it all back together again and can't remember where all the springs are. Also, you can just keep track of all the parts. Now, the actual braking system, if you're buying a complete braking mech, I've had to do that once for a B77, just get the right tool here, that someone sold me from eBay, and it was a very good parts, I have to say, because when I got the lid off this B77, it was in bits. Someone had been at it, and there was also a lot of rusted parts. I bought a complete mech. Now what I'm doing here, again, the same 3-point system of holding like the head block. We are taking three bolt positions of the braking table to release that. The brakes themselves, the brake bolts themselves, they're just standard cheese head with the posi drive bolts, and then the good old Studer crimp washer and a large washer underneath. Do make sure the machine is powered off, for the simple reason, underneath here we've got the spool motors, and of course they've got volts in them, and I have dropped bits down there in the past, which means then you have to take the whole spool motor out to try and get all the bits out of the bell housing, so do keep track of it. The other thing you might want to do, although this makes a handy little receptacle here, sometimes these are filled in with amplifiers. If they had an onboard amp, get yourself a little pot off an aerosol tin or something to put all the bits in there. I've released the bolts there. I'm actually going to, for the sake of this webinar, remove the whole braking platform to just to show you what's underneath it and what it all does. And what I'm doing there is I'm just going to put a bit of slack on the brake bands to ease them off and lift it off, and there it comes off. And that is all we've got on the braking system of most Studers. We've got the two solenoids. They vary from where they are in location. You know, at 820, they're one either side of the motor. In a 62, they were further up the top there. But they are the things that pull in. 24 volts on those. That's the control cable for them. They operate on various actions, and depending on what you're doing in the machine. And of course, they pull in, and you can see the action there. We can also see the brake bands themselves, and we can get hold of the drums. This is quite a good test, actually. What are the bearings like on your spool motors? You can give those a spin. Notice as well, when I'm spinning them, I'm not touching the linings. You don't want to touch the linings of the brakes or get any grease around the inside of the brake bands for obvious reasons. Let's just put it back here. Same thing. Get a bit more slack on the brake bands. Do it one at a time. On a normal brake lineup, you do not need to do this. I was purely doing it to show you the parts of the brake setup. You do not need to do it. However, when you are doing the brake settings, you've changed a brake band over or a brake drum over, you will need to loosen these 3 bolts and move the spool, move the brake table, I should say. And therefore you will need to release these 3 bolts. Just going to put them in, nip them up tight for or reasonably tight so it doesn't move around, and that will be fine for the minute. The brakes are actually, now I can see them, they are actually in wrongly set up, and the reason why I can see that, if you see the gap there and the gap there, that is very, very wide, and that is actually hard up against the lifting pin. When the brakes are set up properly, the gaps between these 2 lifting pins should be identical. So when this solenoid moves, it actions the 2 brake levers at the same time. Right, I'm just going to do the, just get this brake band sorted out here. Be very careful as you put it down. The other thing you do not want to do, and I have checked this band so I can demonstrate it to you, you do not want to get any of these bands creased. Any creasing in this area where it touches the band will mean you have a loss of contact with it and the abrasive material on the drum, and therefore lose braking force. You can, if you're lucky, get the odd crease on these parts here and get away with it, but it's not recommended. Ideally, you want to look after your brake bands, both taking the old ones off and putting the new ones on. I do recommend as well, if you're changing the brake band over, you change the brake drum, which is what we're going to do. So we'll do that now. Parts of that we've got to remove. The spring first. Hold one end of it as you release the other so it doesn't come pinging off across the floor of your workshop. Yes, I have done that on more than one occasion, and I'm scrabbling around looking for the spring. The other thing is you need to remove the two circlips. Now, tools to remove that. These circlips don't have the little rings in them, so you can use a proper pair of circlip pliers. If you had those, you could put them into the two rings, you expand the circlip and you can release it. They don't have that. I would recommend you use circlip pliers rather than trying to bodge it with any other way. However, these C-clip circlips don't have those lifting rings. So I'm going to use the screwdriver method very, very lightly. You put it in here, and this is what I was saying earlier about don't lose the parts down the motor. I hope I haven't lost that. No, I haven't. I think it has dropped down. Never mind. Shows you it's live. Take that one off. And after that, you'll find a washer under there. I checked this the other day, you know, and the circlip came off perfectly. And now it's dropped down there. Well, and we take our brake band off there. So that is our brake band for our tape machine. I just changed angle on the camera there. Can you see there, if I hold it up, can you see there's a kind of kink and a little bit of damage in the machine, in the brake band there and there. So it probably would mean this brake band needs changing. Also, and this is probably, again, I think past the resolution of the camera, but if I compare it with another brake band, you'll find on warm brake bands, there's kind of lines burnt into, run into them. Really bad warm brake bands, I've got black marks, almost friction burns in the brake band because it's been on the drum and in contact with that drum so much. Let's get a brake band. Our new brake bands. And this is a new one from for a B67 or an A807. If you've got an A807, they are different brake bands between the Mark 1s and Mark 2s. The Mark 2 machine, they move the spooling motors slightly apart to get larger reels on there. However, they kept the braking table the same, and as a consequence, you have to have slightly longer your brake bands for it to go around. I've also got these are A80 brake bands, and I've got those to demonstrate that they are also rather short. There we are. They are completely different. If you can see that there, you've got them. The distance on those, or the length of the A80 brake band, is significantly different to the B67, A807, A810 band. Getting new brake bands, you can refurb them. I believe there's an Revox in Australia are offering a refurb kit. I cannot comment on it. I've never used it, but you can buy new brake bands from the likes of Audio House in Switzerland. They are about $50 each. And if I just give you a demonstration, I've told you they're about $50 each. That's what I've just invested in as well for A810. So you can see that there's quite an outlay sometimes in changing brake band systems over. That's $100 for each side, and then you've got your brake drums to throw in as well. So they are not the cheapest things in the world. This is this is, I feel, why a lot of people stick to, oh, recapping and headwear. I said all valid, but they kind of steer clear of some of the mechanical stuff for the simple reason that they're kind of horrified with the prices of it and what they're getting. $50, £55, I think it is, or about the same amount in euros to buy brand new ones of these. So that's your bands. That's what I'm talking. I'm just wondering about where that C-clips drop down to, but I think I can see it at the bottom of the case of the machine. So it hasn't gone in the spooling motor, so we're okay. Shows you what happens on a live webinar. Let's look at our drum now. As I said, that's a good test that the bearings of the spooling motor are running well. It rolls around quite smoothly, and I'm not hearing any graunching and grating as it goes round. Let's remove it. Depending on the machine that you've got, these bolts are either, as you see here, with a straight bolt head on it, or some of them have a cross for a screwdriver, which you can put a flat blade screwdriver in them. Do not use a pair of pliers on them to hold them. You'll only end up rounding the end off and basically making a raunchy mess. The other issue is there's heat involved in here when the brakes, there's friction, and there's also warmth from the motors, and they will have been put in and perhaps left for a good few years. Those bolts can be quite tough to move. Resist the urge to put all your force behind them. Sometimes, and I've done this before, you literally get, and I'm not going to do it on this machine, but you literally get a light mallet and just give it a tap on the top there to break the stiction. But resist the urge to get a great spanner or wrench or something on there and put all your weight behind it to turn it. Put it on there, fingers on the top, so you're not touching the system, the abrasive brake lining. Even if this is a brake drum that I'm going to dispose of, I still want to look after it and remove it. All it consists of is a bolt, a good old Studer. There we are, Studer serrated washer, a larger washer down there. Oh look, magnetic tools. Should really demag those. Magnetic tools. So we've got our serrated washer, which is there, and then finally we turn our attention back to the brake drum itself. We've got this lugged washer in here. Notice you said it's got two ears sticking out of it, and it's also got two flats. The reason being is there's two flats that put it into the top of the post of the capstan motor to give that additional grip. Again, getting those out, you can flick them out with a little screwdriver, or even sometimes just pull them out with your fingers, and that is what you've got there. It only goes back in one way. Depends on how pernickety you are, but actually you can see the stamping there. The top of it's kind of round and the top of it's flat. I like to put them in so the round part is of the stamping when it was made is at the top there. It just looks quite nice. So we've got a drum off there, and we need to take it off. Don't lift it with your fingers. Get some paper. I mean, okay, you can wear gloves if you want, but frankly, I just get some one-shot paper and lift the thing off. It should not come off with a battle. It should just lift off quite smoothly. As you can see, there we are, it goes on. Also, and on and off quite smoothly. Also, notice underneath there and here, there are some packing washers. Those washers are to set the spool height of the machine. They vary, although the manual might say there's 2 or 3. I have had machines, and again, it's the history of the machines where the numbers on each side vary and the thickness of them vary. There are packing washers to make up the anomalies between the spooling motor, which is mounted on the chassis here, the height of the drum, which is an aluminium casting, and then of course the platter that sits on the top. But what happens, especially if people have put a lot of grease on the bearing, that gets onto the washer, which then sticks to the bottom of the drum. You pull the drum off and the washer goes flying off somewhere. So just be aware of that. Again, I'll show you, again, we're getting a little bit out of it, but while we're here, why not? Throw you in some extra information about the machine. Underneath there, that's the bearing of the spool motor, and you can see the various circlips and that rotating around. I'm going to put those washers back on there before we lose them. So our drum, that's a basic brake drum. It's got a notch in it, which is where the lining of the drum ends, and it's just stuck on the inside. See if you can see that there. Just go back to our diagrams here, brake drums. There we are. There's a couple there that I've taken off from past machines. You will notice there, the reason why I've put that up is the wear on them. It will manifest itself by bands around the abrasive material. On the one on the left-hand side, that white line, that's where the abrasive material is wearing away on the pressure of the brake band against it. The one on the right-hand side, and I've done this on just to get some light on it, you can see that they almost start to turn into like glass, a very, very smooth, which indicates that the lining on that brake drum has gone. There's no way that you rejuvenate that. You can rejuvenate brake drums if they're not too far gone by giving them a good clean. And I've actually seen that you can just brush the abrasive material up a little bit more, but it is only extending the life. It's a bit like relapping a head, really. It just extends the life somewhat. It does not turn it to pristine condition. If we also just move on to other brake drums, here's the one on the right-hand side is what we're working on at the moment. That's an original Studer product. I know it's a Studer product because if we just go back to our drum here, I don't know whether you can see that. Can you see in there, incised in there is a number, and it'll say, in this case, 2.067. So it's telling me if it's for a Studer B67 machine, and it's an official Studer product. The drums on here on the right hand side, although they are identical in terms of, or physically identical, and they have this brake lining on them, the shoulders on them are just chamfered off, as opposed to we've got this rounded shoulder on the kind of official product. I've seen those a lot on A807s in the last sort of machines that were produced in 88 and 1990. I've even seen one with green brake linings. When I first advertised this webinar, I did have a picture of one with a green brake lining. I don't know if you know any more about those particular linings and whether they are produced by a third-party company, or there was something that Studer kind of started using toward the end of their manufacturing of tape machines. A good example would be that Studer used to make their own spooling motors and capstan motors, and then later on they got the French company Pabst to make them for them. You'll find that a lot on the A820 machines, that they are not the Studer branded motors. They are French Pabst motors. So maybe they were putting that that product out to a third-party company by then. I don't know. Perhaps you can shed some more light on that. Let's move back to our brake drums. I have been experimenting with refurbing brake drums and playing around with brake linings. This that is the official Studer product there. Let's just put that there, official Studer product. Can we see that there? And let's move those brake bands out of the way. And that is my refurbed lining. What I've done there is taken the drum, stripped the old linings off of it, put a new lining on there and glued it on. Now that is fairly simple to do. The trick is making sure it does the same braking forces that you'd expect, but also that it does it for a long time, because you will find that brakes, and it states in the manual, and it's quite true, brakes need time to bed in. And this is what I've been playing around with from the last year, different materials, different adhesions of a way to stick them on the drum, and then to keep them on there and keep them braking. And I think keep them offering the same amount of braking force. And I think I've got something that works now. So I'm actually experimenting with that. They've been fitted to, I've got an A700 machine and a B77. They've both got these drums on there and have had them for the last 6 to 8 months now. And they both work quite well. I did have one example of material I've been using that it worked perfectly until I decided to clean the brake bands and drums, and I'll show you how to do that with some IPA, isopropyl alcohol, and it promptly dissolved all the glue in them, and then it stuck itself to the band, and it was a horrible old mess. But this is what we're going to use, refurbished drum on this 67, and see how we get on. So we just put this worn drum to one side, putting these drums on. Yes, I'll put it on with a piece of cloth here, so we'll just pop it back on there. The trick we have to do now is line up the two flats on the post of the spooling motor through to the bits so that their lugged washer will fit in smoothly. Now, if you can see that, I'm actually going to move that back to the other camera. It's a bit better resolution there. If you can see that, as I'm rotating, I'm just going to hold that lightly. I'm not going to put the screwdriver in too badly, but I'm just going to hold that. You might be able to see, there we are. It's now stationary because I've got a screwdriver against the flat, and the brake drum is rotating on the rotating around on the post of the spooling motor. So what we need to do is line those up. You can do this sort of shake action and turning them around until they finally line up, or the other thing is just put your little finger in, hold that steady, hold the spooling motor steady, and then just turn it around. They should not be tough to turn. If they are, it means you've got a problem either with the drum or with the spooling motor post. Maybe it's taken a bit of heat and a bit of burring, and it's caused damage, or it's been damaged in some other way, bashed or whatever. You should find that they spin quite freely on that post. Get a washer back, lugged washer back on. It will only go in one way, and there we are. It's nice and snug and in place. We put our large washer back in. We assemble our crimp washer with our bolt. Careful not to drop this one. Make sure it goes in. There we are. Then we get our nut spinner. Just tighten it up. Do not put all your force back on there. As I said earlier about getting these on, you do need to make sure they're reasonably tight. The crimp washer will do the job for you. I have had machines where that has come loose in the past, and the whole thing is rattling around. And at first I wondered if it was a loose spool platter, but then I moved the spool platter and found that the whole brake drum was running up and down on the post of the spool motor. So just make sure that's tightened up. Okay, after that we go back to our brake band. A brake band itself, as I said already on that side, that's to make sure that it's free of kinks. On the opposite side, you might see some tape here and here. This is stuck on there to stop the bands kind of juddering and vibrating. Whether it does anything, I don't know. I have seen ones where it's completely peeled off and the braking system seems to work quite happily, but it's just whether it's to stop vibrations or dampen out any sort of fluctuations in the bands, I don't know, but certainly it comes with this tape. Just pop it on, using the other side as a guide as to what pins you need to drop it down on, and make sure it's all snug, and make sure it's reasonably okay and round, covering the band. As you can see there, it is not, this is the only area of the band you can really hold your fingers. It is not like that from riding up. Okay, it should be there covering the whole band, and you can just test that by pulling the band in tight and making sure it's covering the drum properly. After that, we need to reassemble it. This is where we find we're missing our circlip, but oh well, we'll have to struggle on without that. Get a spring. Again, hold that. Hook that over. You will need to adjust these springs because the position of them, because they will affect the braking force. But initially, just stick them back on the same position as the other side. There, you'll find on each of the bands, and they're identical. You can put them on upside down. It doesn't really matter. But there are 4 holes that these springs can hook onto. By moving this spring to different positions, so if you move it there, it's actually a shorter distance than if you move it there. So you're putting more braking force on the spring by altering the spring position. Although it's only about a centimetre difference between there and there, and you can at a push use you use that hole at the end there, although the lifting pin's starting to foul it. It does make a difference to the braking force. After that, we put our washer back on. Putting these circlips back on, if I have both, can be a bit of a knack, but I just put them all on there and then just push it on with the screw with a pair of pliers, and it just clips on. Yes, we've lost that one. It will be okay. I do not recommend that you put your machine back together with the circlips entirely missing off of it, but for the purpose of this webinar, it will be fine. After that, check it's all fine, it doesn't ride up and down, and before we put the spool platter back on, and everything all seems to be okay. So Broadly, that is your brake band and brake drum changed. And all we're doing is repeating it on the opposite side: circlip, springs, brake band, brake drum, bolts, and the lugged washer, and changing that one as well if we wanted to. I'm just going to put the spool platters back on, because after that we need to do some adjustments to the lifting action, and we also need to do some braking force adjustments so that we know that when we press stop, the brakes work as they expect to. We don't throw loops and we don't snatch the tape. One of the things that I find that having to explain to people sometimes is you're doing a lot of checks on a machine. You actually sometimes have to put the machine all back together to do a check, and then find it's out, and then you have to take everything apart again to adjust it. It's the only way to do it, and this is one of the reasons why maintenance on these machines can be quite time consuming. So, air brakes here, we now need to adjust the lifting pins. I mentioned earlier we've got a pin distance here and a pin distance there. That is actioned, and regardless of the system you've got, A77s through to Air A810s, when the solenoid comes in to lift the brakes off, those two pins here, that pin there and that pin there, have to hit these parts of the brake levers simultaneously. So the first thing we need to do is make sure they do. And quite surprisingly, me just changing these over, they do. But let's assume they don't, and perhaps we find that that lever's out there, and that gap is bigger than that gap. The reason why they need to be the same is the lifting action of the solenoid coming in needs to take the brakes off simultaneously, and that's why that action is critical. To alter that, and this is literally the manual, oh, wrong hex key there. The manual, I love the phrasing of the manuals. They always say, all of the manuals and student manuals state this. Adjust the brakes in a manner, I think, if I remember, adjust the brakes in a certain manner to achieve this. They don't actually describe it at all well. What you are doing is moving the whole spool table from one side from one spool platter to the other, and as you do it, can you see there that the brake levers are moving independently of each other as I'm moving it? It's the action of the levers here are making these move. You're moving them in such a manner, that's the right words, until these two distances are identical. So I just check that again. There we are. Do the lifting pins, and then if I carefully lift it, yep, there we are. They're both coming in. Oh, it's moved again. Again, these are one of the checks that you have to repeat all over again. If you get it wrong, there we are, they're lifting. And after that, we just nip one in, nip the center one in first so it doesn't move and doesn't rotate. Just nip them up so they're reasonably tight, and then check it again. Yeah, we're okay there, so which means we can do these a little bit tighter. If it's not and they're wrong, you've got to go back to square one, loosen all those off, and move the brake platform in such a manner that you get this identical lifting action. There we are. The next thing we need to adjust is this distance between here, the lifting pin, and the brake arm, and it needs to be, they say in the manuals, about 1 millimeter. One sort of 0.8 to 1.2 is fine. Really, you know, we're dealing with mechanics here. This isn't you know, astrophysics, and I find that's fine. But you do need to make sure they're reasonably in that distance. The reason being is the travel on the lifting solenoid needs to be as short as possible. So in other words, when it comes in, the brakes come off fairly quickly, and then the power is to spooling motors applied and the tape moves. You can do that distance with a ruler, a little bit cumbersome. The better idea is if you've got feeler gauges. This is just set to 1 millimeter, and all I'm doing is just passing it through, and I can see. I actually don't. I've done these so many times. I can see that when they're identical and where they're about 1 millimeter. But all you need to do is run your feeler gauge around there. Yeah, that's fine. It's a little bit over 1 millimeter, but it's fine. The crucial thing is there's not a great amount of travel, and it's hitting those lifting pins are hitting the brake bands simultaneously. If you've got the edit action on your machine, the edit solenoid here, that will only come into action when you power the machine up. Great, no smoke coming out from that circlet that's disappeared. Notice there when I powered it up, the top edit solenoid powers up and pulls in the levers there, and these two lifting pins lift here. They need to be the same thing under power. Again, 1 millimeter if you've got them, and you are just adjusting the distances there. It's a little bit under, but I think for the purposes of this, I mean, it's infinitesimally small, and I'm going to let that go. But if you need to adjust those, that is what you're doing. You're putting the machine under power. The edit solenoid comes in and lifts those pins away from the lever, from the brake bands. If you need to adjust your braking, the actual action of these brakes moving, you need to adjust your edit solenoid and your brake solenoid positioning, because they would dictate how far this lever moves. Similarly with the edit lever, how far they go in. I'm not going to adjust those in this webinar because I'm afraid we'll probably be here for another half an hour to get that sorted out, and they look good to me. There is a good lesson here. If it ain't broke, don't fix it. You release those or release those, and it allows you to move the solenoids independently of the solenoid plunger to get the lifting action as they move in. But this looks good. Quite honestly, a lot of the edit solenoid action will be dictated by the position of the brake platform and the braking solenoid. So if this one looks good, chances are that one's going to be good as well. We can then just test it without any tape. We can see there's action there, that it's lifting off simultaneously, and also take a listen to it. Yeah, that's fine. Now there's one thing, actually, I'll just jump the gun, which I should have demonstrated to you, which you can do. We only need to do this on one spool, and that is give those bands and drums a clean. You recall I told you about when I was working on different materials for replacement brake bands. Just take that away. And I clean the drums. The one I'm cleaning them with is good old isopropyl alcohol. I buy this stuff, it's about $3 a tin from various electrical suppliers, and a cotton bud. Just spray a little bit of that. Camera. We can clean the band and we can clean the drum. And the way to clean that, other way, is just run it around from the bottom to the top of the drum. It's similar if I was doing this side, I'd do the bottom to the top of the drum there. What that's doing is giving the drum a clean, giving the band a clean. And if you want to clean the drum, you can do that out of the machine, or you can just gently give it a clean there. I said this is the rejuvenation process if you want to try and get some life back into your drums, but quite honestly, it's putting some life back in. It is not returning to as normal. But this is a good method to clean them because, you know, inadvertently you put your fingers on them, perhaps when you're changing the bands over, when we need to move them, like doing that and maybe knocking the band down a little bit, and you might got a bit of grease on them. Test it again. Yeah, that's good. As you can see, it's dropping it in a nice smooth manner there. I'm taking the power off. It's not jerking. It's a nice smooth braking action. So that is what we're doing. And you can do to clean them. And you can do that with any machine of any make, really. I've done it on TIACs and Tascams. I've done it on Sonys. That's the way you clean the bands. Resist the urge to soak them too much. Turn the machine off. To soak them too much, because you might find that the abrasive material doesn't like being soaked too much in alcohol. That's what happened to the materials I was using, that the glue was dissolved by the isopropyl alcohol and then all gummed up inside of the brake band, and it was a right old mess, and wrote the brake band off, as well as making time to take everything out and clean it up. The whole brake band just went solid, and I had to take everything off, and it was all messy and jammed around the band. And I thought, well, we're not going to be using that material for refurbished brake bands. And there we are. We have now set the basics up of our braking system, but we still don't know what this braking action is, because how do we know if we go into fast forward, rewind, turn the power off, it's not going to spew tape about or grab the tape and turn it into a bootlace. What we are going to use is, just look at my bits here, the manual tells you, get yourself a reel of tape, around a 100mm diameter hub. It's the hub diameter which is the important bit. Luckily for most nab hubs, they are about 100mm. If you've got a machine like I was talking about, the little TIAC, which only takes 7-inch reels, you probably got to put a bit more tape on there to get up to whatever they specify. Sometimes it's 70mm, sometimes it's 100mm hub. It is not the diameter of the reel that's important, it's the hub diameter that we are dealing with. And what I've done here, we've got an inch reel of tape. You know, I even made that up purposefully. It says, look, braking force reel there. I made this probably up in about 1990, this reel, and I've still got it. Piece of tape on there, and all I've got is a loop at the end of it to do the braking force reel. So what am I doing? Let's just go back to, we'll come on to that in a minute with this particular image. This is taken from the Studio A810 manual. But all of the manuals are the same. They illustrate, and indeed, I've looked at TIAC, Tascam, Sony manuals. They all kind of specify the same things. With a spring balance, you are setting up the braking forces, and that is either in, and don't get too bamboozled with the numbers here, it's either in newtons, as they call it, or P's, which is actually grams, and that's 1/10 of the newton. So I always go from the grams, 80 to 110 grams. With your spring balance, you are taking you are measuring the braking force by putting this reel of tape onto the hub, and then with the machine in the appropriate mode, as in powered up, so the brakes are engaged. You are then pulling the, sorry, not powered up, so the brakes aren't engaged, or are engaged, I should say. Let's get right. Machine's not powered up, brakes are engaged. You are pulling the reel off and measuring the braking force. Notice as well the braking forces are different depending on the direction of the reel. So if we're going on this particular, on the take-up spool in an anti-clockwise direction, it's only 80 to 110 grams. But if we're going in the anti-clockwise direction, on the braking, it's 260 to 320 grams. Quite a wide range, but it's in that range. But it's in that area that it is 3 times. That you remember the rule of 3. That one brake, the brake, for instance, if it's on fast forward, you're fast forwarding, the supply reel needs to be braking at 260 to 320 grams, whereas the take-up spool, so we're moving here, needs to brake only at 100 or 80 to 110 grams. It's doing lesser braking. That it will stop your tape spooling all off of the machine. If they were reversed, what of course would happen is that they would probably, it would actually certainly happen, it would spool off the machine, but if they were too high, it would snatch the tape if the supply side was way too high and out of spec. So it's the rule of thirds. It's a third of the take-up side is a third of the supply side and the braking forces, and also the braking forces between each other must be no different than about 50 grams, and that holds good for any tape machine. So we need to do those tests. So we've got our reel of tape here. Let's go back to our machine again. We need to set the machine up exactly as it's if it's taking some tape. So I'm going to be doing our supply side here. Lock our machine down exactly as if we were playing some tape, and I'm going to be checking our braking force. After that, you need spring balances. These particular things here, they are the kind of things that you would probably, you know, some of these are like market traders or whatever might be measuring out their fruit and veg. They are just a standard spring balance. This particular one goes up to 1,000 grams a kilogram. So I'll just show that to you there. This one there is does 2 kilograms, and I've even got a Meteor one there, which oh, that goes up to 2 kilograms as well. But the kind of balances you're looking for, you are using them as well in the horizontal planes. You need to make sure that they're calibrated, that at least it's in the rest state, that 0 point there. The marker is on the 0, so you know that when you pull the spring balance out, you're getting a good reading. I'm going to be using this one up to for our braking force, because all I'm looking for on sorry, that's a lie. I'm going to use this one because I'm looking for. No, we stop. I'm going to use this one because we are looking for marks of around 200 to 300 grams, 320, when we pull the tape off the reel. Again, going back to our diagram here, this is what I'm going to be doing. It's on the left-hand side in a anti-clockwise manner, and we're looking for a breaking force of 260 to 320 grams. So let's have a look at that. I'm pulling that off. Unfortunately, you probably won't be able to see this too well, but all I'm doing is literally pulling the, with the brakes engaged, I'm just pulling this off of the, this tape off of the reel, and I'm checking the measurement. And at the moment, it's saying it is 275 grams. Wait, when you do these checks, perhaps if I pull it around here, you might be able to see, when you do these checks, you have to have a steady state pull. You can't just pull it away and jerk it away, because it will give you a false reading. So there we are, it's coming out about 270, 280 grams. So at the moment, that is in spec on that side. Similarly, I need to check if it was in rewind, what the braking force would be like. So I check it here. This is obviously, this is the machine going around in a clockwise direction. Rewind our tape back there, and I'm looking between 80 and 110 grams for this. So a lot lighter force. You'll see that there, it moves quite easily. Make sure we don't get any catching there, which can give us a false reading. It's actually a little bit high, this one. It's coming out at about 130, 140. We live in the real world, and frankly, I am going to let that go for the purpose of this, for that one. But I'm going to show you how you would adjust it if it was radically out on this particular reel. So this one here, we are looking for a braking force of 260 to 320, because the machine will be in rewind, and this needs to add the major braking force to it, making sure we're okay there. Pull it out there, and we're actually on the money there. It's at 300 grams there. But I'm going to show you what we do. Just check it one more time. Yeah, maybe 280. We call it a bit on the low side. Take your reel off, and you're turning your attention to, you need a pair of pliers. You're turning your attention to this spring here. This one here, I'm afraid you can't, let's take the spool platform off, but the spring itself down there, let's put it on the camera there, that's better. You are moving this spring to adjust the braking force, and the more you, the further you, the further you, this is what I was saying about always hold on to them, because they're pinging off, and then you're going to lose them. That's better. Make sure it's locked in. No. There you go. You are moving this spring. I'm actually increasing the braking force. The way to show you, actually, if I take the spring entirely off, there we are, pop it down there. That's that is without any springs on the braking band, and the brake is just ineffectual, and the spool is just spinning around, freewheeling. So we are putting this spring on to pull that braking band in, and adjusting the braking force accordingly. Holding a spring. There we are, it's one hook. Adjust it there. And it is a little bit of trial and error, I'm afraid. Again, this is going back to setting the whole thing up again, putting all the spool back on, bolting things up as you need to, getting the conditions for your test set up, and then just pulling it and doing the test again. And this has gone down. It's gone down to about 230, 240. So it's demonstrated that moving that spring position just a little bit has altered the braking force. So if I went back to that position, the original position, and again using the rule of if it ain't broke, don't fix it. If that's what it is, and that's where it was before, just because you put a new brake band on, so be it. That is it. Don't think you have to do anything radically different just because you fitted new parts. Parts of the springs are perfectly okay. Just going up, yep, we are back up to about 280 grams as I'm pulling the tape off the reel. You will find, although we've concentrated on changing the brake drums and the brake band, these springs will stretch. And if they are showing any stretch, you will need to change them. Studer, Revox do sell those springs, but I have been using generic ones in the past, which I know of particular braking force, and they've worked very, very well. It's quite a soft metal, and it's very easy to stretch them. But again, if you put too tougher ones on there, these poor old brake drums are just unable to move, and they're just locked on. So you do need to use the right spring material. But it is not a special, you know, made in the Swiss Alps. Spring by Singing Nuns or whatever. That is a standard machine part, just as like the bearings were on these machines. They're standard machine parts, and if you can get the right spring with the right tensions, they'll be fine. But you might need to consider those. Invariably they're okay, but any sense of stretch on them around here, it's best to replace them. So we've got our brakes here. Now there's one final thing that Studer do recommend, which I do not agree with, because I think it's a bit of a bodge. Let's just go back to our diagrams here. And that is the brake band itself. If you can see, this is a used brake band. Studer might say that if you cannot get the readings you want, then bend the arm of the brake band to get the right reading. Well, clearly someone here has almost hammered it around the lifting pin. This is a particular band I took off a machine. I don't quite know what happened there, but this is in an attempt to get the distance. We go back to our brake drums here, the distance under tension a bit more, so as to pull these bands together. And they've done it by rather a bodge of bending out the spring. I've seen others where they have bent the arm out at an angle as well, just to get that separation distance higher. I do not agree with doing that. I much would prefer to have a setup where the brake springs and the brake bands are all nice, and it just looks nice. And the reason why they're probably resorting to having to put that bend in the spring is either the brake bands have got damage, the brake drums are worn, or the spring here is just past its best, and it is really a mess. You've really got to say no, put new parts on there, and indeed you've probably got to do it on both sides, so we get good braking force to do the brakes on the machine. Then the final thing we come to is the acid test. We are going to put some tape back on there again. Always gash tape, always set the machine up. Let's take the risk. I know we've lost that circlip, but let's take the risk of not putting the deck plate back on, because that's more work for us to do. Although you will find if the tape does throw great loops, and it will mangle itself all around the internals of the machine, but that's just the risk we take. Line the machine up. Check it. Yeah, the brake, the edit levers are coming up. There, I don't know whether you can see that just in there. There we are. You can see that moving there as I switch the machine on. Put the machine into fast forward, and just do a normal operation on the machine. Yeah, it stops. Just go into rewind. Normal operation on the machine. Yes, we're relying on the spool motor electronic action, but we're also relying on the brakes, and everything's fine. Now let's just do the acid test. I suspect this one will be fine, because I haven't really adjusted this braking here. Yes, it is. That one's fine. It's stopping the brakes. Let's just get it into a bit more tape. I want to get it up into a little bit more speed. Okay, here we go. We're going to put it into a good rewind speed, and we're going to see what happens. Yeah, that's not bad. Notice there's a little bit of a loop there. Now, one of the reasons, don't get fooled by the fact that your brakes perhaps aren't as good as they are. You've gone through all the braking measurements with their spring balance and pulling the tape out, and you're happy that that's all okay. But when you're doing this acid test, oh, wrong way, that's better. You're doing this acid test that you're still getting a bit of a loop. There we are. It's a good example there. It's a bit bigger of a loop than I'd expect. Don't get fooled that perhaps the brakes aren't right and aren't doing their job. You have to have brakes to give brakes a bedding in time, and to give them a little bit of abrasion between the brakes and the braking band and the drum. One of the ways you can do this is just put the machine into wind, and there's literally, as you can see I'm doing there, holding the band, squeezing the band, and you can see that's an action on the drum. Don't do this for too long. You're actually stalling the motor, which is not doing it a great amount of favors. But you're just going to bed the drum in. And of course, in time, like all things, perhaps it's a bit like when you tune a piano. It's perfectly in tune, and then it actually might improve with time as the tuning, as the piano settles down with the atmospheric conditions, and then it starts to go out of tune. It's the same with the brakes. You might get a period where the brakes are a little bit low, and then they'll start to go through a nice period where they're not throwing loops, where there's everything smooth and slowing down, and then as the brakes start to wear, you're losing some braking action. So really that is the basics of setting up the brakes on Studer Revox machines. And I said a lot of that is applicable to other machines. You'll see the way I'm cleaning the bands, replacing those. I can't comment on, we look at our, let's just go back here. Oh, there we are. Go back to the likes of our Sony, for instance, and the way you were making adjustments here with bending the arm. Clearly you can't hear, but Sony are obviously changing. You can see there they've got a spring action there, which is broadly the same as the spring between the two ends of the braking arm on our Studer Revox machines. You are altering the position there, and therefore changing the action of the spring or the brake band on the drum there. I'd like to just throw in a few things to wrap up really now, because we've been going an hour and a quarter on a Q&A. I've had a few questions come in. One of them was saying that they had a Studio A80 that had loads of smoke coming out the back of it. I'm afraid that is your riffers that are going pop, your riffer capacitors, which are across your motors. It'll manifest itself by lots of smoke coming out there, and usually a sharp crack like that. Not the end of the world, but you will need to get them replaced. I don't, unfortunately, have any pictures of what blown riffers look like, but they are large gold-looking capacitors. They are probably about 2 centimeters, 2.5 centimeters wide by about 1 centimeter wide and high, and they blow up like a big balloon and then go crack because they've got a plastic case, and then that's all the smoke comes after them. They are used across the motors of the machine for torque purposes to keep the machine rolling. With age, like any component, those A80s, like this B67, date from the 1970s, and I'm afraid components age, and eventually they die, and they do that in the most spectacular way. One other question has come in as well, as to, which is unrelated to brakes, but I'll answer it anyway, is noise reduction. And should you use noise reduction in your recording? Well, I'd say it's entirely up to you. The manufacturers, in an attempt to extend the quality and the life of tape, introduced various noise reduction systems. The obvious one is Dolby. The system started with the Type A and moved on to the the SR, and in professional use. And you probably, if you've got a cassette deck, would have seen Dolby B and C, all various sort of, and there's HX as well, which is another one that played around with the bias. And there was DBX as well, which is another noise reduction system. They are companding systems. They will have an effect on the audio that you record on the tape. The idea being is it's to increase the noise, the signal to noise ratio between the noise of the tape and the signal you're putting on, and to increase that distance and therefore make the signal cleaner. Yes, they will have an effect on the tape, and of course once they're recorded on there, you have to then replay them, decode them, as might be a terminology for them, or for noise reduction encoded tapes. When you replay it, you decode it with the appropriate noise reduction system. Dolby A, you need Dolby A decoders. Dolby C on your cassette deck, you should really play with Dolby C on. It's entirely up to you. I personally feel that all of the great heyday of tape machines from the 1960s through to the 70s, yeah, okay, noise reduction was coming in the late 70s, but really it was good enough then. And so why do we want to tweak around with the audio? okay if you want to compare it with digital recording where you've got signal to noise ratios of 90 dBs or so. You perhaps want to use noise reduction to try and give a bit more life to analog recording, but I feel just go with it. If you want to use it, that's it. If you don't want to use it, don't use it. It's entirely up to you. Have a play around, have a comparison. If you want to record some material, do it with your DBX system or your Dolby A's or your SRs or whatever, if you're in the professional market, and see what it sounds like, and then commit to it. Final one I've got here, is it possible to get a recording of the webinar? Yes, I've had several questions on that. Yes, it will be. The webinar is being recorded. I did have a big mistake of recording the first webinar. I didn't record it. I didn't press record on the Zoom, but luckily I did record it on the cameras that you see here. So I have actually remade the first webinar, cut it down and edited it. And I will be putting that on the YouTube channel, the Real Resilience YouTube channel, as sections, because it's 74 minutes long. I'll do the same with this one, I think, rather than getting rid of some of the preamble that we don't need to talk about. And the final question, I think, before we close, it says, could you describe at high level how similar, different the Atari MX550 braking system is to this? The short answer is, in this webinar, no. I have an Atari MX50, which is another one that in a similar state to this, a B67. It's a bit like the plumber's dripping tap. He never gets around to fixing his own plumbing. I know that the braking system on that is behind the spool platters, but I believe it's behind the deck plate as well on the 550. What I'm happy to do is I will go and look at the 550 manual. I do have it in my office, and get back to you on that if that's okay, because I don't want to give you some false information on this webinar. So that's it really. The details that you might require if you wish to get in touch with me. We just move on here to the final bits of the presentation. Real Resilience, as I've spoken to you about, AV Resilience is my studio company that that Real Resilience came off the back of, because my background is originally, as I was trained by the BBC in all aspects of audio, and I built studios in other areas. I built a lot of podcasting studios and other equipment for podcasters. People asked me to do tape machines, so Real Resilience came off the back of that. So they're the details, and they're the two websites. I do apologise, the Real Resilience email has had continuing problems with it, I'm afraid. So use that one there, though it's info@avresilience.co.uk if you wish to drop me a line, and I'll pick that up. Real Resilience is still the Gmail one. I tried to do a info@realresilience.co.uk, and it is a complete mess. It keeps bouncing sometimes it works, and I can't get to the bottom of it. It's clearly a masking issue, and I'm just going to go back to square one with it when I get some time. So at the moment, please email me at realresilience@gmail.com. The website I've told you about, what you can find on there with access to the podcast as well. We have the shop, and also you'll find the YouTube channel. Details aren't there on there, but I'll add those about the YouTube channel Real Resilience, where you'll find all the episodes of Press Play and other videos that I'll be putting up as and when. Please drop me a line. I'm UK based. If you want to give me a call, office hours only, so please allow for the time difference from 9 to 5. I'm happy to take calls, or just drop me an email or drop me a message via Facebook, or even you can get me on LinkedIn, and I'll be happy to talk. So I thank you very, very much for your time on this webinar. We will be running another one, perhaps in another couple of months' time, when I can find some more time. And in the meantime, I wish you the best of the rest of the day you've got. And as I always say at the end of my Press Play podcasts, let's keep it real. Thank you very much.